Welcome to practical number 3. Hmm? So today's practical is basically about capacitors as well as transistors. Before moving to that, I have to do a minor correction, right, related to practical number 2. So you can remember we did a practical with 2 LEDs, right? We did a 2 LEDs like this with a common resistor. This is ground. So if you connect to 5 volt, one is red LED, this is red, this is green. So you know that the red one will forward bias, but the green one will not. Okay. But the thing is that when I'm doing this last time, the red color red color LED that I selected was defective. Okay, because of that, okay, the red LED turn off and green LED turn on, right? But it should be normally the red one will turn on, the green one will turn off. Okay, so we'll do it. I found all the resistors that we used last time, resistors as well as LED last time. Wait for a moment. I think this is the red. We have 220 ohms resistor. Quickly, I can see that the red one is turn on. Okay, this red one is this is a defective red. This is a defective red. That's the reason. Okay, this one having a larger voltage compared to the typical one. So normally when we connected red LED and green LED, this green is also defective one. No, it's not defective. When we connect the red LED and the green LED, the red LED having less potential, 2 volt, this may be 2.2 volt. Therefore, red one will light properly, the green one will not. Here you can see this one was defective, that's why you have higher brightness in the green one. Okay. සාමාන්‍යයෙන් වෙන්නේ red එක තමයි පත්තු වෙන්නේ, green එක පත්තු වෙන්නේ නැති වෙනවා. මතකනේ මේක අපි කතා කරේ. Okay. So we will move into today's session. Today we are going to discuss about capacitors. Okay. So capacitor is a two-terminal electronic device. Capacitor, usually we have used parallel plate capacitors for any object. There is a capacitor. This charge, voltage, and capacitance is given by Q equals Z, we know. And the C is given by, when it is a parallel plate capacitor, C is given by epsilon over D. So this is a parallel plate capacitor. Area, cross-section area, permittivity of the material or medium, and D is the distance. So those are the things that we should know. So in your package, you can find several types of capacitors. Okay, there may be a capacitor like this, or maybe this black color. So you can see that this is a 100 microfarad capacitance is measured 100 microfarad capacitor. Sometimes it may be 100 microfarad or maybe 10 microfarad type. This is 10 microfarad capacitor. You see, 10 microfarad. 25 volt means the maximum voltage that you can provide this 25 volt. Sometimes you can find the 100 microfarad capacitor, or sometimes it may be 10 microfarad capacitor. So in addition to that, there are various other capacitors. This is 1000 microfarad. This is 1000 microfarad capacitor. And micro nano is smaller than micro. No? You can find some green color capacitors. They are nanofarad capacitors. Okay. So today we are going to use this cylindrical type capacitor. This is 10 microfarad or 100 microfarad. Okay. So usually one terminal is longer than other terminal. One terminal is longer than other terminal. The side you can see this negative symbol. Negative symbol means this is the negative terminal, right? Normally during the construction, one terminal is constructed little bit difference compared to the other terminal. Usually when we draw the circuit symbol, the biggest one is the negative terminal. One is bigger. This is negative terminal and this is the positive terminal, because this terminal is designed or displayed is designed to capture more electrons, right? This is for opposite of electrons. That's why there's a maximum voltage that you can store. Normally the charging curve will be something like this with respect to time. If you provide a voltage, if you connect this across a battery, this will be charged. If you connect it to 9 volt battery, after longer time it will charge to 9 volts, right? Initially there will be a quick charge and quick voltage increment, but when the time is infinity, it is charged to the applied voltage. If you connect a battery, let's say you have 9 volt battery, then with respect to time, this is how its voltage is changed. So if you short circuit these two terminals, if you remove these two battery and if you connect it through a resistor, then this charge voltage will be quickly discharged. Right? These are exponential relations. So during under the electrical section, you have to obtain these equations, proper equations, just to know the shape. Mathematically, we can obtain these equations. Right? This is called charging curve and discharging curve. So we can obtain the equation of charging curve and discharging curve separately. Then you can exactly analyze this. At the moment, you have to treat it like that, right? So we are going to construct a very simple circuit. So if you turn to page number 7, no, I think if you turn to page number 7, you can find this the charge. Actually, this charge means this should be voltage. Huh? This charging discharge. This is voltage and time. Huh? Voltage and time. I have taken all these curves from internet. So we are going to construct a simple circuit. Okay, look at. So initially, what we are going to do is so we are going to construct a simple transistor circuit. Simple transistor circuit. This is supply volt. We are dealing with 9 volt. This terminal will be grounded. Here we are going to use a resistor and an LED. Typical circuit that we use. This is 220 ohms. Okay. And this is 100 kilo ohms that we use. First we are going to construct this circuit. Okay. ඔයාලට පුළුවන් ඒක හදන්න ඉස්සෙල්ලා circuit එක breadboard එකේ ඔය ගමන් හදන් යන්නකො. හදන් යන්න. you have to use VC5 547 transistor, which is very common transistor that we use. 547 කියන මේක connect කරලා LED එක මුලින් දාලා resistor එක දාන්න පුළුවන්. මොනවද විතර කරන්න පුළුවන්. 220 ohms resistor. Okay, you can remember 100K is the brown, black, yellow one. 100K is connected across supply voltage and the base terminal. Supply voltage and the base terminal. Okay. When we set it like this, you can remember this how the now in this orientation, collector is the top one, emitter is the bottom one, base is the middle one. So you can take your battery. Sometimes your battery may be dead this time, then you have to use a new battery. So this is the typical circuit that we constructed so far. So in this circuit, what you have to do is, all of you, when you are following this, if you are fast and if you are slow, you can pause and do it, right? So what I'm going to do here is, yes, what I'm going to do here is I'm going to use a switch also. Switch can use the switch no, right? Switch එකකුත් ඔයාලට set කරගන්න පුළුවන්. කොහෙටද switch එක දාන්න ඕන? base resistor එකට, right? Base resistor එකට switch එකකුත් දාගන්න. There are different types of switches, so you can use one of the switch එක through තමයි ඇවිල්ලා තියෙන්නේ. Then when we connect it to the supply, it will not turn on, it will only turn on when we press this button. Okay, button එක ගොම තමයි. That's it, right? So then what I'm going to do is I'm going to take one of the capacitors available. So I'm going to connect the capacitor across the base terminal and the emitter terminal. Base එකයි emitter එකයි. Positive terminal is of the capacitor is connected to the base, and the negative terminal of the capacitor is connected to the emitter. Okay, now see, there කලින් circuit එකම තමයි the simple circuit that we use so far, right? Only thing is I set a switch to the and the capacitor. You press them now. Right, I am going to release. Okay, I'm going to release. When I press this, it's turned on. Even though I release it, you can see that this is this LED, the brightness of the LED decreasing gradually. It's not. If you take some time, if you keep this for considerable time, you can see that the brightness will plus. You can see that it's gradually decreasing. Still a little bit brightness available, right? Because this capacitor is acting as a battery now. Right? When we press this, discharge, then gradually discharge. So मैं short circuit करना मैं देखो. So I just short circuit the two terminals of the capacitor. So when I short circuit, what happens is, when I short circuit, what happens is capacitance is capacitor is suddenly discharged, then this LED is purely turn off. So what I did was I took a capacitor. The positive terminal of the capacitor is connected to the base terminal, while the other one is grounded. Right? So when I push the button, normal phenomena happen. At the same time, this will be charged. Usually the base emitter voltage will be 0.7 volt. Therefore, this will be, I think this will be only charged to 0.7, or sometimes there will be initially there will be a current flow to the capacitor. Therefore, sometimes this will be charged more than 0.7. Anyway, this capacitor is charged. So when we turn off the switch, the capacitor is acting as a battery, right? Capacitor is acting as a battery. So you have supply here. So you can use a switch here. Use a switch, capacitor will be charged, right? So then if you see something like this, so an LED. So initially you are going to connect this part, then you are going to remove this and going to connect into this one. Then what happens is again capacitor will be discharged, but the discharging time is very small because this will be a 10 microfarad or 100 microfarad capacitor that we are using. Therefore, you can't visibly see this. But when it is discharging through the transistor, that you know that transistor's base current is very small. Even if you connect it to 9 volt, if you apply Q equals CV, C is 10 micron, pico, nano, micro, milli. The voltage may be 9 volt. You can see that it is 19 to 10 to the power minus 6 coulomb. So very little amount. If it is discharged within 1 second, this current is Q divided by T is time. Q divided by T is, let's say this is discharged within 1 second. Q divided by T is I is equal to Q over T. Then current is very small, several microampere. That is, for LED it is required to supply several milliamperes. So therefore, this switching circuit will work, right? This switching circuit will work. ඔයාලට පුළුවන් පොඩ්ඩක් මේක අර මම හදලා බැලුවා වගේ හදලා බලන්න. So better to pause this end, right? මේක this charge is remain for a considerable time if you use 10 microfarad capacitor. If you use a 100 microfarad capacitor, all of you, time will be greater. එතන මම දැන් use කරලා තියෙන 10 microfarad. Look at discharging time, still discharging. So I'm going to remove this and I'm going to use, I have a 10 microfarad capacitor, 100 microfarad capacitor. සාමාන්‍ය දෙකෙන් එකක් තමයි මම ඔයාලට දීලා ඇත්තේ. Okay, now I am going to push the button. When I push, right now, I think through the camera it is not visible. You can see that the time is larger. It should be 10 times the previous time. වෙලාව ටිකක් වැඩිපුර යනවා කලින්ට වැඩි. Okay, now I'm going to do something else. Okay, this is you see, this is 1000 microfarad capacitor. The 1000 one, this bigger one is 1000 farad one. So I'm going to connect that 1000 farad capacitor across the base and emitter. Okay, initially charge එකක් තියෙනවා. You see that side. Okay, now I'm going to press the push button. You see, I'm going to press 1, 2, 3, push. See that there is no any response. 1, 2, 3. 1, 2, 3. Oh, Now you can see that it is coming. Okay, even I release, is remaining, because 1000 microfarad is considerable one. Usually 1000 microfarad capacitor is the one used in the, that is smooth in circuit rectification එකේදී පාවිච්චි කරන capacitor එකක් ඔයාලා මතකයිනේ අර මොකද්ද සුමට කරන්න කියලා දානවා කියලා smoothing capacitor in the rectification. So this is the one used, right? So why that initially I'm going to discharge this එකක් සාමාන්‍ය රුපියල් 25ක් විතර වෙනවා මේ capacitor එක මම එකක් කිව්වනේ පිටිය ලෝ එක. Why initially when I push this button no any output, because still the capacitor is not charging, that's why. ටිකක් වෙලා ගිහිලා තමයි ආවේ දැක්කනේ. ඒකත් gradually තමයි ආවේ. Okay, so that is all about the capacitors. හදලා බලන්න පුළුවන්. In your case you have to use either 10 microfarad capacitor or 100 microfarad capacitor. You can remember when two capacitors are in series, capacitance is reduced. When the two capacitors are in parallel, capacitance is increased. So you can use the two 10 microfarad capacitors. So 200 microfarad capacitors, you can connect them parallelly and see, you can visualize this. Okay, කල්ල බලන්න. Okay, I'm going to share my multimeter display. Okay, so what I'm going to do is I'm going to measure the voltage across the capacitor. Voltage across the capacitor. So you can see that initially it is 0. So I'm going to push the button, right? I'm going to press the button, push button. Something wrong with my terminals. I have set to 2.5 scale. That means you have to read through the 2.5. ඔයාලට පස්සේ Arduino board එකකිනුත් මේක බලන්න පුළුවන් voltmeter එකක් හදලා. Later I will explain how to construct your own voltmeter by using Arduino. Right? Now you can see that initial charges you have to 250 කින් බලන්න ඕනේ. 250 කින් it is discharging. I am using 1000 microfarad capacitor. That's why you can see this gradually. So now when I press the button, you can see that voltage is increasing. 50 කියන්නේ 0.5. 50 60 the silicon, therefore it will stop at 0.7. Clear? So when I release this, the voltage will gradually decrease. Graph එකේ තිබ්බේ voltage එක වැඩි වෙන එක අඩු වෙන එක. If you measure or if you plot with respect to time, you can obtain the same graph that we discussed. Right? Gradually decrease වෙලා යනවා. මම මේ දෙක short circuit කරලා දාන්න හදන එකක් ගාලා capacitor එකේ terminals එක. You see that suddenly voltage difference is set to 0. Okay, right. You can construct your own multimeter later, right? Multimeter means voltmeter, basically voltmeter, but by using Arduino board, and you can measure this kind of voltages. If you have already done the second Arduino practical, that means you know how to construct your own with your computer and Arduino board, how to construct your own voltmeter. With that voltmeter you can measure this voltage, right? Otherwise later I will when you are watching the second Arduino practical, you can see it, right? So in the practical sheet, this circuit is available now. This circuit is available. Actually in my case, I push button, then the 100k resistor here, and capacitor is directly connected to base terminal. Here the capacitor is connected to other side of the, not directly to the base terminal, it is connected to the resistor in between resistor and the switch, then the advantage is the discharging happening through the resistor. No? Therefore, again there will be a current control or current limiting. That's why this is so. Anyway, if you connect the capacitor directly to base terminal without through this resistor, it is also fine. Right? Okay, so that is the first practice circuit of the practical number 3. Then we have to move into another circuit. It is also very famous circuit called multivibrator circuit. Okay, I will guide you for this. Right, multivibrator circuit. Multivibrator circuit is a very simple circuit, but according to my experience, I know that normally if I ask a student to do this, they will not complete this. Right? Definitely, with the hands-on practical, I know that normally 50% of the students will complete this circuit properly. There will be different faults with the circuit. So initially, what you have to do is you have to construct this simple circuit. Okay, this is 100K, 220 ohms resistor LED. This capacitor is not required in this case. Okay, so you have to construct this circuit. Right? You have to construct 2 such circuits in the breadboard. One side you can construct this circuit, other side you can construct the same copy, or we call carbon copy of the same circuit. 220 ohms resistor, LED, 100K, right? That is the first thing you have to do. බලන්නකො හදන්න එක වගේ circuit දෙකක් හදාගන්න. එක වගේ circuit දෙකක් හදාගන්න ඕන. So this is the first circuit that I have constructed. First circuit that I have constructed. LED එකයි series එකකුයි 1K එකකුයි තියෙන්නේ. ඒතර ඒකට supply එක දීලා ඒක හරිද කියලා බලන්න. ඒක මම මේ වගේ තව එකක් හදන්න ඕන. You have to construct another circuit. You have to use similar components. Another 457, 547, another 547. 547 තව එකක් ගන්න ඕන. BC 547 එකක් ගන්න ඕන. LED, you can use another different color or same color. LED එක කොහොම ගැහුවත් ප්‍රශ්නයක් නැහැ නේ. LED එක මුලින් ගැහුවත් ප්‍රශ්නයක් නැහැ. ඉස්සෙල්ලා ගැහුවත් ප්‍රශ්නයක් නැහැ. LED එක resistor එක මාරුවට කමක් නැහැ නේ. 220 ohms resistor. Red, brown. And 1K. 1K, brown, black, yellow. Brown, black, yellow. Yes. එකත් වෙනම check කරලා බලන්නකො වැඩ කරනවද කියලා. Okay, so you have to give the power for it and check. හරියට check කරලා බලන්න. දෙකේම එකම එළිය එන්න ඕන, right? Normally when you check two LEDs separately, two circuits separately, they must be identical. In my case, there was something wrong with my PC547 transistor, I think, because I have used these transistors for various applications and so on. So now what you have to do is you have to connect these two together such that I'm going to connect this positive side to positive side. First I'm going to connect first two rows together and the base terminal emitter terminals together. Emitters දෙකත් එකට connect කරගන්න. Then what happened? Within one supply, they will work, no? දෙකම පත්තු වෙනවා. Within one supply. එක supply එකකින් දෙකම එන ගන්නට හදාගන්න. එකම විදියට පත්තු වෙන්න ඕන. Okay. What I did is something like this. බලන්න මෙහෙම කරන්න ඕන. You have to, because you have used either side of the breadboard. You know that first row having 5 pins. Again, there's the separator and another 5 pins. So these two are not connected together. So you can use a jumper, and by using a jumper, you can connect these two together. Then with one supply, your supply may be here, no 9-volt battery. We only provide positive and negative connection to one side. They are connected, therefore both the LEDs will be light in same brightness, right? If brightness are different, your circuit may not be identical. There may be some connection fault or component fault. Normally component fault එකක් කෙනෙක් නැහැ. If you have a misconnection, there will be two different brightness. Become brightness again. You can use two different LEDs, no harm. Two different colors, right? එකම වගේ brightness එක එන්න ඕන. Then the special part. Look at, you have to take two capacitors, two identical capacitors. Usually you have used 10 microfarad capacitor, 100 microfarad capacitor. So what you have to do is the base terminal. What you have to do is this. Look at all of you. For the collector terminal, all of you. For the collector terminal, you have to connect a capacitor, the positive terminal of the capacitor, right? For this one also, this is a collector terminal. You have to connect a capacitor, the positive terminal of the capacitor. Okay. For both capacitors, you have to connect both transistors. You have to connect two capacitors. The positive terminal of the capacitor is connected to the collector. Positive is connected to the collector. Then the negative side, this negative terminal must be connected to the base. Must be connected to the base of the other transistor. This collector is connected to the base through this capacitor. This collector is connected to this base through this capacitor, right? So normally what you can do is, so you can connect positive terminal to capacitor, positive terminal to collector, positive terminal to collector, and connect the negative terminal to one of the three rows available. One of the three rows available. Through a jumper, you can connect. Through a jumper wire, you can connect this negative terminal of the capacitor with the base terminal. Look at. If you do this carefully, only you can see the multivibrator circuit. Someone is called multivibrator means we have two LEDs. No, one is turn on at that time, other one is off, like this, right? This is the multivibrator. Robo circuit කියලා කියන robo gas එකක් on වෙනකොට අනිත් එක off වෙනවා වගේ scene එකක් එනවා. හරි? It's also called robo circuit. We'll see. Okay, so these two wires are used to this red. This is used for yellow color. Is used to connect the positive sides together. So you have to take a capacitor. I'm going to use 10 microfarad capacitor. So this longer terminal is connected to the left-hand side transistors collector terminal. Left-hand side transistors collector terminal. Collector එකට connect කරන්න. අනිත් එක මෙහෙම පල්ලෙහා පැත්තට ගෙන්න. Right? So other side is connected to not to the one connected to the emitter, right? Emitter එක connect කරලා තියෙන එකට පල්ලෙහා එකට connect කරලා තියෙන්නේ. ඒ උඩ පැත්ත එක connect කරලා තියෙන collector එක. So I'm going to repeat the same process for the other side. The longer terminal is connected to the collector. Other one is connected to one of the free rows available, right? Then this terminal, this negative terminal must be connected to the base of the other side. So you have to take another wire. A negative terminal එක connect කරලා තියෙන තැන තියෙනවා මෙතන. That negative terminal must be connected to the base of the other side. Base of the other negative terminal to base of the other side. So repeat the same process for other one. Repeat the same process for other one. We have black color wire here. Center connect කරලා පැත්තේ base එකට connect කරන්න ඕන. Base එක කියලා කියන්නේ මැද එක. Base එක කියන transistor මැද එකට connect කරන්න ඕන. You have to do this very carefully, neatly and all, right? Then only you can see this kind of this is called multivibration. Right? Normally this will be the frequency when we use charging discharging frequency, when we use 10 microfarad capacitor, but you can use 100 microfarad capacitor. If it is 100 microfarad capacitor, you can see, right? අලගාව ඇති සමහරලාට මෙන්න මෙහෙම මේ PF එකක් මෙන්න මේ වගේ PF capacitors ඇති අර ඕනනම් ඔයාලට පුළුවන් එකක් දාලා බලන්න. What I did here is one side is 10 microfarad, other side is that this green color capacitor. It is non-pole capacitor. This capacitor is called non-pole capacitor. That means there is no any positive or negative terminal. There is no any difference between positive and negative. Therefore, you can use it. So that part having a small capacitance, though, that's why this kind of blink. You can see that this is continuously turned on, but it is also අර කලින් එකම තමයි වෙන්නේ. But this is blinking, right? Only little blink එකක් තමයි මේකේ තියෙන්නේ. Normally when we construct a circuit, really it works, right? That's it. Normally when we construct a circuit by using this kind of component, we call discrete components. Whenever component අරන් හැදුවම normally the circuit works very rare. If you construct 10 circuits, one will work. That's a typical theory behind practical circuit constructions, right? Theoretically they will work, but practically there can be a lot of issues. හරි දැන් ඔයාලා උනත් දැන් මේක හදනකොට අනිවාර්යෙන් මේ මම හදක දැන් ගොඩක් හදලා ගන්න හින්දා වැඩ කරාට definitely there will be a mistake. So you have to troubleshoot. It's a very patiently, you have to do it very patiently. හරි ඉවසීම හොඳට තියෙද කියලා බලන්න පුළුවන් වැඩක් මේක කරලා බලන්න පුළුවන්. Actually, the theory behind this circuit is little bit complicated. Actually, it's difficult to explain the circuit with the current knowledge, current knowledge that you have. This in this diagram, this is the one. This is the resistor. It says you have to use 470 ohms. We use 220 ohms LED, right? This is the transistor, and this is the 100K instead of 470K, 100K you can use. This is the same thing. LED එක ඇවිල්ලා මෙහෙම switch එක හරහා යනවනේ, switch එක මේ පැත්තට දීලා තියෙනවා. මේ what we did was මේ diagram එක අපි මේ පැත්තෙන් ඇඳලා තියෙන මේ base එක, අනිත් පැත්ත හරවලා ඇඳලා තියෙන base එක මේ පැත්තට වෙන්න ඇඳලා තියෙනවා. So you can see that the collector terminal is connected to the base through this capacitor. The collector terminal is connected to the base through this capacitor එක. පැහැදිලිව පෙන්වන්න තමයි මේ විදිහට ඇඳලා තියෙන්නේ. So actually this is kind of balance situation, two identical circuit balance. We have two capacitors. We have two capacitors now. Actually, with the current knowledge, it is difficult to explain this circuit, right? This is called bit stable multivibrator circuit. That is the, I think, proper name. I learned it in the university. මේක මේ පොඩි ළමයි හදනවා. මමත් මේ circuit එක සාමාන්‍ය 7 වසරේදී වගේ තමයි මුලින්ම හැදුවේ. ඔයාලත් මම හිතන්නේ හදලා ඇති. But in order to explain this properly, you should know the proper circuit analysis, AC theory and all. So this is a kind of RCL circuit. So you have to use differential equations and so on in order to analyze it. So simply what happens is we have two containers. They are initially set in balance. We are going to charge them. That means we are going to fill these two. But even though they are identical means same microfarad. They are definitely they are not identical, same value, but other properties may be different. Therefore, one will quickly charge. When it is quickly charged, it will there will be unbalanced situation. Right? So when this side is going down, it is set to discharge automatically. When it is more weight, it will go down. When it is going down, it is set to discharge. When it is discharge, what happens? It will go up suddenly. So what is going down will automatically discharge. Therefore, that kind of behavior is available. That's a simple way of explaining this. Okay. So we did the two practicals in the page number 6 of the handout, right? The first one is called delay time. For the delay එකක් දාගන්න ඕන. This is a typical circuit that we use. That is a delay time, right? But now due to the current trends, modern developments of circuits, we don't have to use this kind of hardware circuits to make a delay. For example, when it is an Arduino programming situation, we will realize that by using a function, we can make a simple delay. Earlier, we had to use the capacitor to maintain a delay with this kind of circuit, right? So this is a multivibrator circuit. One is on, other one is on at the same time, and we have to continuously do that. So we can use for loop එකක් වගේ දාලා නැත්නම් by using several functions, we can easily program Arduino board or something like that, right? So what I'm doing all these things to give you some feeling about basic electronics and all that side. Okay. Then we are moving to water detector circuit. Water detector circuit, page number 7. Okay, before moving to water detector, I forget to tell you something. Look at this demonstration. It's a capacitor, right? So I'm going to connect it across this 9-volt battery directly. Okay. Now this is 9-volt battery. No? This will be charged to 9 volt. මේක ගහලා තියෙන්නේ 25 volt කියලා නේ. Maximum voltage is 25. මේක burn වෙන්නේ නැහැ. Otherwise this will be burned out, right? If you connect this 25 volt 10 microfarad capacitor, maximum voltage that can handle is 25 volt. If you provide more than that, this will burn, right? Now I'm going to disconnect. Then I have an LED. Look, I'm going to connect this LED across these two terminals. You see little light up. Okay, පොඩි වෙලාවකට ඒක පත් වෙලා ගියා. That is the discharging time, visible discharging time. So earlier we used that capacitor, sorry, that delay circuit and did the අයින් කරලා එහෙම charge කරන පොඩ්ඩක් වෙලා. Now it is charged, right? Within 1 second it will be charged. Then connect LED across it. එකනේ පොඩි blink එකක් ඇවිල්ලා ගියේ. That's it. Then we are moving to the water detector circuit. So water detector circuit means simply transistor, LED, and better to have a resistor here, and the base is collected to supply volt 9 volt or 6 volt through the water. That's it. Okay. All of you. So I have to take one BC547. BC547 LED resistor. Resistor එකක් දාන්න 220 ohms resistor එක. If it is not available 220 ohms, use the nearest resistor available. මේක අපි typical circuit එක හදලා බලන්නකො ඉස්සෙල්ලා 100k එකක් දාලා. Typical circuit I am going to construct. Typical transistor circuit. As a typical circuit. So remove the 100k resistor and connect two wires. One is to 5 volt or 9 volt supply volt. The one is to the base terminal, right? Even if you short circuit these two, it will turn on for maybe lose connection in my circuit, but better to not to do this, huh? So you can take water, put the two terminals into water. Okay, you take one out of water, no connection. Now this water is acting as the base resistor. Water has certain amount of resistance. That's a simple water detector circuit. So you can change the sensitivity of this circuit. You can change the sensitivity of this circuit by using another resistor like this. What I did here is, all of you, I did not use this VR1 කියන එක use කරේ නෑ, right? If you want, you can use a this is now this circuit, this is R1 and this is R2, no? It's a variable resistor in between base and emitter. Other resistor in between base and the 5 volt. Right now, this will act as a potential divider. So if you want to change the sensitivity of your circuit, you can use a variable resistor here. Right? Ek adjust කරගන්න පුළුවන්. ඒතකොට වතුර level එක, actually this will not give the water level exactly. Little bit related with the depth. So you can change this you can change the sensitivity. Yeah? Sensitivity එක වෙනස් කරගන්න පුළුවන්. Let's say kit එකේ by using the variable resistor. You know how to use a variable resistor? Usually better to have a large value here, right? When it is conducting, high value here. Okay, that's a simple water detector circuit. Then we are moving to two transistor switching called two-stage switches. Okay, so first what you have to do is you have to simply construct the first circuit. First circuit, you can easily construct this circuit. This is the light detector that we have constructed earlier. So better to use a 1K resistor here, 1K resistor, 1K capacitor, and you can use LED also. LED, then you can see visible output. No? That's it. So later we can connect the other LED and observe. It's two-stage switching. හදන්න බලන්න. මුලින්ම අර light detector circuit එක හදලා ඉන්න. ඊට පස්සේ හදන්න මේ two stage තව stage එකකට BC547 එකක්ම තමයි තව connect කරලා තියෙන්නේ. මත් හදන්න යන්නේ. උත්තර භාජනය අයින් කරලා මොකද බලන්න. We want BC547 LED 220 ohms resistor, LDR between the supply voltage and the base. Supply base and we have to use 1 kilo ohms resistor, 1K, brown, black, red between base and emitter. There were a lot of comments related to the previous LDR practical. Okay, sensor light detector. Now you can see it's light. No, light is available when I cover this. It will turn off. This is a light detector. Okay, so actually I'm using several studio lights here. So I'm going to turn off the studio light. You can see still this is not dark, no, because I have used other CFL bulb here. Normally CFL bulbs, okay, normally CFL bulbs, LEDs, all of you, normally LDR is sensitive to the resistance of the LDR related with all the frequencies. Normally when it is a CFL or LED lamp, right, you can see the room is light up, but it is just one few limited frequencies will be emitted by those lights. Therefore let's say you are doing the practical in the night. That means your light source is not the sunlight, no. Light source is the light available at home, your room. Okay, that will actually, you can see that you can see your room because of that light, but actually your room is in dark because only limited frequencies are available. Therefore, if you do it in the sunlight, then all the frequencies are available, right? In my case also, you can see that now this is a light detector, right? Light is available, light is the CFL bulb. That is not sufficient. When I turn on this studio light, then we have considerable light, then the light detector is detected. That's why some of you ask me, sir, that is not working, even that detector circuit is not working. It is not a problem of the LDR. ගොඩක් කට්ටිය මේ LDR එක පිච්චිලා කියලා අර මේ කිව්වා. It is not a problem of the LDR. It is a problem with the light source that you have. අර torch එකක් වගේ ගහුවොත්, if you use a torch or something like that, then it will be fine, right? Okay, so this is the LDR, LDR and the typical light detector circuit what we have constructed here. First you have to construct it. මේක මුලින් හදන්න. ඒක මුලින් හදන්න. හදලා ඊට පස්සේ අපි ඒකට stage එකක් ඉස්සරහට ගෙනියමු. Two stages. All of you. Now, this is the LDR circuit that we constructed, right? So we are going to use another similar circuit here. (220 ohms) resistor. This is BC547 NPN transistor. This is also BC547 NPN transistor, right? So you can connect these two together. You can directly connect these two. What happened? Depending on the collector voltage, base emitter voltage, this one will control, no? This is called two-stage switches. We'll construct and see. Practically, there are some issues with this circuit. We'll see. So we have already constructed that, the light detector circuit here. Okay, light detector circuit. So we are going to construct another similar circuit. We have to use another BC547. This is BC547 LED. LED. And 220 ohms resistor. Red, brown. Okay, නැත්තම් මේක ගන්න හරි. This is the 5 volt. Okay, so I have to use another wire to connect the grounds together. A ground connect. Now I have connected the grounds together. Then one more connection. The collector of the first transistor. Collector of the first transistor must be connected to the base of the second transistor. Second stage, first stage to second stage. Okay, 5 volt is connected now, and going to make it dark. Dark. Yeah, but some issues with my circuit also. So this is the expected circuit. Now, this what we have constructed is a light detector, right? Now the light is available. That's why first LED is on. Okay, with 2 stages. Now light is not available, so you can assume that the first LED is off. First LED is off. Okay, at that time second LED is on. I'm not sure whether your circuit will work, right? Okay. With ambient light conditions and all, this will be very sensitive circuit. This is dark. So two LEDs acting as two different indicators. Make a opposite logic එක තමයි මෙතන තියෙන්නේ. When the first one is off, second one is on. Right? මේක කියනවා light කියන එක, මේක කියනවා dark කියන එක. මගේ මේ remote එකෙන් මම මේක off කරන්න පුළුවන්. off කරාම light off කරාම පස්සේ dark sensor එක. මේක dark එක detect වෙනවා. light එක වගේ අත පොඩ්ඩක් ගන්න ඕන මේක වෙන වෙන ඒවට මේක. ඊළඟ මේ තිබ්බන් පස්සේ okay, I will explain what is happening in this two-stage amplifier, two-stage switch. So I use a resistor here, right? Use a resistor. It is not available in the. I use 100k resistor here, 100k resistor. We'll see what happens. When it is light, let's say light is available. When the light is available, this resistance is low. No? This resistance is low. Therefore, this potential difference will be low. This potential difference will be high. This is high value. This is a higher value. This will be a lower value. Light. Okay. Therefore, it is sufficient to turn on the transistor. So, therefore, there will be a current flow. That's why this LED is on. This is on. This is the light detector. When light is available, low resistance, low potential difference, higher potential difference compared to that, conducting the current. Right? Normally, you see that when this is on, theoretically this must be off. Not sure whether it is working practically. Okay. Better to use the 100 kilo ohms resistor in between these two. Otherwise, what happen is, I will explain otherwise what happened. So when this is turned on, so the collector emitter voltage will be normally when this is saturated, collector emitter voltage you have heard about 0.2 volt. Likewise, when this current is high, this potential difference will be low value. That means this side having a lower value. This side having a lower value means the base emitter voltage is low, means the current conduction is low. That's why this is switch off, right? When it is light, let's say dark, this is high, this is low. This is low means this current is very small. Current is zero. When current is zero, all of you, when current is zero, there is no any current flow. When current is zero, the potential difference across this circuit will be very low. Across this resistor is zero, right? In other words, the given potential difference, 9 volt will be here. Not actually 9 volt, some kind of 9 volt will be here. Make a nෑ කියලා හිතන්නත් පුළුවන් ඔයාලට. Let's say this is not available only the resistor. Then in this branch there is no any current flow. No? In this branch there is no any current flow. No any current flow means the supply voltage is across this collector and emitter. That means it will be high value. It's a high value means this will turn on. That is what is happening. But there's another thing going here. Always there is a current flow in this direction. Current, kind of leakage current. By using this resistor, you can avoid that leakage current. Okay. Anyway, there will be a leakage current, because therefore always this one will try to turn on. I think in my setup I use 1k resistor here, 1 kilo ohm, right? 1 kilo ohm, 100 kilo ohms. Then that visible effect is possible. Otherwise, this circuit will not work. This will work, but it will not visible to us. That's why you will not uh, realize this effect. Okay, better to try it. Circuit එකක් හදිස්සියෙන් වැඩ කරන්නේ නැතුව ගණන් ගන්න එපා. මගේ ගණන් තාම වැඩ කරනවා වගේ මම හිතන්නේ. ලයිට් එක පැත්තට අල්ලලා බලමු. දැන් පොඩ්ඩක් මේක දාලා. Okay, okay. Now I have removed the link between stage 1 and stage 2. So when it is just one stage, you can see that the dark detector, now it is dark detector, okay, light detector, dark detector, light detector. But when I connect this yellow color wire is the one connecting the collector to base, okay, through the 100 kilo ohms resistor. Now you can see that just after I connect it, even it is in dark, this LED is just turn on a little bit. That is because of the leakage current I mentioned. I will turn on more lights, then I think, yes. When I turn on more lights, you can see that now the light is available. Therefore, the second LED is off, right? And I'm going to turn off the lights, right? Now light off color. Now it is dark. Therefore, second LED is on. එකක් අනිත් එකේ opposite එක විදියට තමයි වැඩ කරන්නේ. Right. So ඒක පොඩ්ඩක් එහෙම මෙහෙ කරලා බලන්න එක පාට වැඩ කරන්නේ නැහැ ඔය මේ මගේ එකත් හරියට ආවේ නැහැ. ලයිට් පොඩ්ඩක් වෙනස් කරලා ගත්තම තමයි හරි ගියේ. So you can use this resistor. Here you can use this. You can use a different resistor here, or variable resistor, and check, right? So now this is a two-stage amplifier, or two-stage switch with the same type of transistor, NPN transistor. When this is when this voltage is high, this will be low. When there is a current conduction in this branch, this branch current conduction will be low. When this current is high, that current will be low. When this current is low, that current will be high. That's how when we have, if you use another stage, that one will operate like this. Okay. So here, instead of using NPN transistor, instead of using an NPN transistor, we are going to use a PNP transistor for stage 2. PNP transistor for stage 2. Okay. So this is the symbol of PNP transistor. This is the symbol of the PNP transistor. මේ ඔක්කොම NPN නේ කලින් තිබ්බේවා. NPN, PNP transistor. So if you connect like that, you know that the current flow here collector to emitter direction. Now here it will be base to emitter direction, emitter to collector direction. So what we can do is we can invert this, put the emitter upward and collector downward, and put this one. Therefore there is no any effect. Therefore the direction of the current flow is same, but it is replaced with a PNP transistor. BC557 is the identical pair transistor. Normally when it is a transistor, NPN transistor, you can find equivalent PNP transistor. 547 තියෙන එක තියෙන එකට තියෙන 557 කියලා. ඒ වගේ එහෙම තියෙනවා pairs. හරි. So In your package, you can find BC557 transistor. In BC557 transistor, its package, if you look at it from the top, මේක තියෙන්නේ මෙහෙමනේ. මේක උඩින් බැලුවොත් පේන්නේ මේ විදිහටනේ collector emitter base. මේකත් එහෙමම තමයි. Collector base emitter. Same collector emitter base, right? So now what we have to do is we have to මේක ඔයාලා දාලා තියෙන්නේ මේ පැත්තටනේ. Now you have to interchange the two, therefore you have to connect it like this. So simply remove the BC547 and insert BC557. Right? So this is the first time that you are going to use PNP transistor. I want to get in touch with PNP. That's right. Okay. We'll see whether it is going well. So now you can see that I have fixed the transistor. Okay. මේක දාලා තියෙන පැත්තට නෙමෙයි මේක අනිත් පැත්තට වෙන්න දාලා තියෙන්නේ. The collector emitter is in upper side, the collector is in lower side. Okay. Now what happens is when the light is detected, this LED is on. At the same time, this one is also on. That means both LEDs or both switches maintain the same logic. Clear? So back to board. Earlier what happened was the transistors are working like opposite logics, no? මේ LED එක on වෙනකොට මේක off වුණානේ. On, off, off, on. That was the situation. Now let's say it is light. Light means conducting a current. Okay, conducting a current. When this is on, this is also on. And I think yes, let's say when this is on, the voltage at this point is 5 volt. Okay, this one is 5 volt. 5 volt. This one, let's say 4 volt or 5 volt. Anyway, there's a voltage. So the meter, the base emitter voltage is the important one. Normally when the base emitter voltage, when the base emitter is greater than 0.7, the transistor will turn on. Now the base emitter compared to emitter base voltage, right? Here it's the opposite direction. Compared to emitter, compared to emitter, the base voltage is less than 0.7. This will turn on, right? Let's say this is non-conducting. If this is non-conducting, the 9 volt will be here. Here also 9 volt. It is not conducting, non-conducting. The 9 compared to emitter, base voltage is here 9. 9 minus 4, 5 volt. Compared to emitter, base voltage is a negative volt. That means less than 0.7. Right? It should be less than minus 0.7. Okay. So it is less than 0.7. Right? Therefore, the transistor will turn on. Look at the other case, that is easy. When this is when it is dark, there is no any current. No? There is no any current. That means this potential will be here. There are 9 volt. Here also same 9 volt. Right? 9 volt. When the conducting, this voltage will change. Let's say non-conducting 9 volt, 9 volt. There is no any difference between these two. That means the base emitter voltage is 0. That means transistor is not turned on. When this is turned off, this is also turned off. Earlier, when this is turned off, this, if we are using pair of NPN, when one transistor is on, other transistor will be off. Right? Now, when one is on, other one is also on. Both on at the same time, both off at the same time. That is the logic. Right? So here I want to introduce a simple circuit with 2 stages. One stage, this is the second stage. For the second stage, if you use the same type, NPN and NPN, එකක් on වෙනකොට අනිත් එක off වෙනවා. Off වෙනකොට on වෙනවා. If you use NPN transistor and PNP transistor, then you can maintain both on at the same time, both off at the same time. That is the importance of the opposite one, NPN, PNP. Okay, you can try this. Sometimes there may be issues with your circuit. අර මේ කලින් තිබ්බ එක අයින් කරලා එතෙන්ට දාන්න BC547. Okay. So you can see the characteristic curve of BC547. All of you, I have put the characteristic curve of BC557, which is NPN PNP transistor. No? It's a pin configuration, right? Here, the direction of the base current, normally base current coming into the transistor. No? Now the currents are මේ පැත්තට තියෙන්නේ ඒ වගේ. Okay, emitter current is the larger current. No? Emitter එක යන පැත්තටමනේ collector එක යන්නේ. Right? The emitter, the collector current plus base current is equal to emitter current. So this is the direction of base current. So it is opposite to the previous direction. That's why the minus is here. The minus කියලා දාලා තියෙන්නේ ඒක. If you look at the characteristic curve of BC547, 547 previous one, එකත් ඔය වගේම තමයි මෙතන තියෙන්නේ base currents තියෙන්නේ positive. Base currents are positive. These volt all are positive, right? Now the sign is changed. Sign is changed. All the these directions are changed. When it is a PNP transistor, PNP transistor compared to NPN transistor, you have to change the directions, all the directions, right? Okay. If you want, you can try a simple circuit like this. Let's say you want to construct the very simple circuit very simple transistor circuit that we constructed earlier. We construct කරේ මෙන්න මේක නේද? මෙහෙමනේ ගත්තේ. So if you want to construct the same one by using PNP transistor, okay, here now direction of current flow, this is positive, negative. Direction of current flow is different, therefore you have to put positive terminal here, and here must be the negative terminal, right? Then you have, when you are putting LED, you have to put the LED in opposite direction, because direction of current flow is opposite. And you must connect this resistor to the positive terminal. That's how you have to construct. මේක තමයි අර අතන අපි අනිත් පැත්තට ගහලා තිබුණා. මොකද අපි we maintain the same LED direction. You can try this circuit also. You can use 100K here, 100K, 220 ohms resistor. You must connect the LED in opposite direction, right? So if you maintain the positive voltage here and negative voltage here, not like this positive here, negative, you have to change the direction of the transistor, emitter and collector interchange, and you can maintain the diode in the downward direction, right? You get what I mean? Okay, that's why we use මේකටම ගහන්න ඕන. මේ විදිහට තමයි මේ circuit එකට connect කරනවා. Connect කරන්නේ. Okay, so in this practical we discuss about capacitors and transistors. Further about transistors, we discuss two-stage amplification or two-stage switching, as well as we discuss NPN transistor. If you are using both pairs, PNP, NPN together, then we can maintain continuous logic. Otherwise, logic will be opposite. That's right. Okay. Okay. So during the next practical, we are going to discuss about the diodes. Okay. Stay safe. මේවා කරගෙන යද්දි මොන හරි ප්‍රශ්න තිබ්බොත් ඕන වෙලාවකදී you can contact me, right? එකපාරම contact කරන්න යන්න එපා. You better to try several times. දැන් කට්ටිය මට කතා කරලා කියනවා LDR එක පිච්චිලා කියනවා. breadboard එක පිච්චිලා කියනවා. එහෙම වෙන්න බෑ හරිද? breadboard වගේ ඒවා පිච්චෙන්නේ නැහැ කොහොමද? So try it several times and you can contact me at any time. Other thing is that, so all these are recorded sessions now. So I highly recommend your comments. Can be either positive comments or negative comments, whatever. Unari comment එකක් දාන්න. එතකොට I feel that you are following this and you are following this and you are in contact with me, then I feel the same feeling that we conduct a live sessions or physical sessions. ඊළඟ එක කරනකොට පොඩි ගැම්මක් වෙනවා. Okay, stay safe.